Okay, another problem. Again, find the reactions. And in this particular case, again, it's a beam with, hinge and a roller. And you draw your initial free body diagram here. You can draw your final free body diagram here. Okay, so work this problem, pause the video. In this particular case, it's obvious that AX equals 0, so I'm not even going to show it in the free body diagram. But what we have is we have an AY and a BY. We put those in there. I'm now going to take moments about A equals 0. So there's my center of my clock. So it's 15 times 11. 8 times 5, by times 7, and then the signs for the 15, that's clockwise, so it's positive. For the 8, that's clockwise, so it's positive. For the by, it's counterclockwise, so it's negative. So positive, positive, negative. We solve for by, get 29.3 kips. Now we're going to take moments about B equals 0. So I'm taking moments about this point. So I have 15 times 18, 8 times 12, AY times 7, and then clockwise positive, clockwise positive, clockwise positive. So they're all positive. All of these are positive. I solve for AY. Get AY as negative 52.3, which means that now the arrow is going to go down. Positive 52.3. Then we have the 29.3 from here. And what do we see? Does up equal down? Well, what do we have? We've got all of these going up, and they sum to 52.3. I have that one going down. It's 52.3, so yes, up equals down. We don't want to do this. I don't like to see the... So I don't want you to show this negative 52.3 pointing upward, okay? Technically it's correct, but it's non-standard, so I don't accept it. You have to show positive numbers in your free body diagram. I don't want to see any negative numbers. I'll take points off if you show negative numbers in your final free body diagram. Okay, another one. You just got to keep going. You got to get this right. If you're making mistakes, find out where your mistakes are. Keep going. Find the reactions for this one. So pause the video. Do this one. And what do we have? Here's our free body diagram. I think you should be able to do those by now. And I'm going to take some of the moments about A. So here's A. So it's going to be 6 times 5. 12 times 2, by times 8, 8 times 11, and then what are the signs? So counterclockwise, negative. Clockwise, positive. Counterclockwise, negative. Counterclockwise, negative. Solve for by using algebra. Set everything equal to 0. Solve for by using algebra. We got negative 11.75. Now we're going to take moments about b equals 0. So there's the center of my clock. So I have 6 times 13, ay times 8, 12 times 6, 8 times 3. And then the signs, counterclockwise, negative. Clockwise, positive. Counterclockwise, negative. Counterclockwise, negative. So those are all the signs. And we solve for AY, 21.75. So what do we, again, BX equals 0, sum of forces in the x direction equals 0. So we have, with that, what do? I flip it around, put a positive 11.75, so that's there, that's going upward. And then we check, does up equal down? And what do we find? We have what's going up. I've got these two, 29.75 going up. I have 18, 11.75, 29.75 going down. So yes, what's going up is equal to what's going down. We can move forward. Another one. Pause the video, do this one. Here's our free body diagram. I'm not going to go through it. You can all do that now. So again, moments about A. It's going to be 8 times 4. BY times 6. 12 times 9. And this is going to be negative because it's counterclockwise. Counterclockwise there, it's negative. Clockwise there, it's positive. All reflected in this expression. We solve for BY, we get 12.7. Take moments about B equals 0. There's my, so I'm going to have 8 times 10. AY times 6, 12 times 3, and this is going to be counterclockwise, so it's negative, clockwise, so it's positive, clockwise is positive. Solve for AY, we get 7.3. Both of these are positive, so it makes everything easy. BX is 0. And so there's our final free body diagram. We do our check. We have 20 going down. We have 20 going up. Another one. Do this, pause the video. Again, we have our free body diagram here, so we're working straight from this. Remember to work from the free body diagram. AX is 0, so we're going to skip that. I take moments about A, so I'm going to have 5 times 2. I'm going to have BY times 6. 3 times 9. 4 times 12, 8 times 16, and then in terms of the signs, clockwise positive, counterclockwise negative, counterclockwise negative, clockwise positive, clockwise positive. So all that goes into this expression. We get BY is equal to 26.5 kips. Take moments about B. I have 5 times 8. AY times 6. 3 times 3. 4 times 6. 8 times 10. And then what are the signs? Clockwise positive, clockwise positive, counterclockwise negative, clockwise positive, clockwise positive. So all that goes into this expression. We solve for AY negative 22.5, which means what? We have to flip the arrow around, flip that arrow around, it points downward now. 22.5, 26.5. And if what's going upward, we have that goes up, that goes up, that goes up, which is 34.5. And we have that goes down, that goes down, that goes down, also 34.5. So we can go forward. We can fill in those blanks as well. Another one, pause the video, do this one. And we have our initial free body diagram. Taking moments about A, I'm going to have 5 times 2, 7 times 6, BY times 9, and then in terms of the signs, clockwise positive, counterclockwise negative, counterclockwise negative. We put all that into here. We get BY as negative 3.56 kilonewtons. Take moments about B. We have AY times 9, 5 times 7, 7 times 3. And then for the signs, clockwise positive, counterclockwise negative, clockwise positive. We put those into this expression. I get AY as 1.56 kilonewtons. And so again, this is a negative, so you know I don't want to see that. I want you to flip the arrow around and show a positive value. So again, what do we see? You know, again, remember that the reactions are what the supports put on the beam. So again, in this particular case, what we're showing is point B is pulling the beam downward. And you might say, well, it can't do that because it's going to lift off this. But remember, this is just a schematic. It's not exactly, it looks more like this, or here's an image of, for instance, a wheel of a roller coaster car. This is what it looks like. So this is what a roller looks like. It confines everything, up, down, sideways in this particular case. Even though our schematic is that, you know, what you got to think about is something that looks more like that or this. So this is okay. It's not going to lift off because this is just a schematic. Okay, so this is again is our diving board problem. You can see it's a diving board here, and so to emphasize the meaning of the reactions, I'm not going to go through this. Remember, with the diving board is going to deform like that. And you can pause the video and look at the reactions. I'm not going to go through them for this particular one because we've already gone through it. But I want to emphasize that that here's the final free body diagram for our diving board. And at this location, at the hinge, what are we doing? We're holding that diving board down, which means that if the hinge is pulling the diving board down, that means the diving board is lifting the hinge up. So in other words, we're going to get into this in more detail. This is not a complete free body diagram, but what we're going to find when we draw what we call adjacent free body diagrams, at a point, I have to have equal and opposite forces. In other words, the hinge is pulling this down, and we show that in that free body diagram. If we were going to draw a free body diagram of the hinge, then I have to show that the diving board is pulling up by an equal amount. They're both 10 kips. So to emphasize this, that this is up, this is down, and they have to be equal. Similarly, at the roller, if we were going to make a free body diagram of the roller, this is 20 kips going up, then that's got to be 20 kips going down. Equal and opposite at that particular point. So in other words, I'm looking at point B, I'm looking at point A. If I'm looking at the top free body diagram for point A, that's up here, 10 kips going down. If I'm looking also at point A, but the bottom free body diagram, they've got to be equal and opposite. And the same thing, equal and opposite at that point, depending on whether we're looking at the upper or lower free body diagram. So sometimes that's the way we're going to be looking at things in more detail. Now, just as an aside here, if you're going to design the support for the diving board, what do you have to do? You have to make sure that that support there can resist, the 10 kips going up. And what do you need? You may need an anchor in the ground to hold that thing down. So these are the sorts of things that go into the design of structures that you have to think about. So again, the reactions show what the supports are doing to the beam. But the beam is doing something to the supports too. So using the equal and opposite concept, we can see what the beam is doing to the supports. So when you're designing, you have to design not only the beam, you also have to design the supports. In this class, we're sort of focusing on the beam. Another one, pause the video, you can do this one. Do it real quickly again. We have, moments about A. We're going to have 5 times 4, 8 times 6, by times 9, 12 times 15, and that's going to be clockwise positive, counterclockwise negative, counterclockwise negative, counterclockwise negative. And solve that, we get by is negative 23.1. Moments about B, ay times 9, 5 times 5, 8 times 3, 12 times 6, and clockwise positive, counterclockwise negative, clockwise positive, counterclockwise negative. Those go into this expression. We get 8.1. Again, we flip this around, put a positive 23.1. The 8.1 just goes in directly there. The AX is 0. And what we find is upward force is a 28.1. The down is 28.1. So up is equal to down. And again, what do we see? If this is, we may need to anchor this roller. Why? Because we will be, what we find is that the beam pulls upward, lifts upward. That support lifts that support upward. Another one, pause the video. A lot of them, I want you to get this down. I know it's a lot of them, but you need to get these right and keep doing them. Okay, so now I'm just going to go through it quickly. It's going to be, we're taking moments about A, 4 times 4, 5 times 2, BY times 7, 7 times 12, and then clockwise positive, counterclockwise negative, clockwise positive. Put it all in, we get 15.7 for BY. Moments about B, it's going to be 4 times 11, AY times 7, 5 times 5, 7 times 5, and then the signs, clockwise positive, counterclockwise negative, clockwise positive. Put it all in, we get negative 7.7, so we flip the arrow around, we put them like that, and then we find that the upward forces are 19.7, the downward forces are 19.7, so we're happy with that. Another one, pause the video, do this. We're almost done with this, but keep going. You got to get these right. Moments about A, 12 times 5, 9 times 5, 3 times 9, BY times 12, and then clockwise positive, counterclockwise negative, clockwise positive, counterclockwise negative. Moments about B, 12 times 17, AY times 12, 9 times 7, 3 times 3, and the signs, clockwise positive, counterclockwise negative. Should be getting pretty good at this, so we put all these in, we get our values, that's negative 21.5, that's positive 3.5, so we flip that arrow around, make it positive number 21.5, 3.5, we don't flip anything around. If we get 24.5 for the upward forces, 24.5 for the downward forces. Okay, I'll stop there. That is all of the ones with vertical loads. What we're going to get into is what happens if the load is not vertical. And that will be the next what we look at.